I think I've mentioned countless times that the whole idea of statistics is that we learn how to use samples and the characteristics we measure in those samples, so our sample statistics. We use sample statistics to help us estimate or predict what's going on in the population. So we're trying to estimate population parameters. The whole idea is that we can't directly measure, for whatever reason, the population. Maybe it's too large, it's too hard to get in touch with, it's costs too much money. Whatever the reason is, we can't directly observe the population, so we have to rely on sample statistics to point the way. Now, of course, one of the biggest issues with this is that samples are often, very often wrong. Now, that doesn't necessarily mean that they're useless, but what it does mean is that if you were to randomly draw a sample from your population, you can almost guarantee that it's not going to be a perfect representation of the population. It's going to either, whatever it is you're trying to estimate, whether, let's say we have a population and we're trying to estimate how tall people in the population are. So we take a sample of that population. Well, there's a very good chance we're either going to have a sample that overestimates or underestimates. Now, that's okay. We don't expect our samples to be perfect, and in fact, much of what you learn about in this course is how to deal with what's called sampling error, how to deal with this imperfect process. But one thing that we can't deal with is when there is bias in our estimators, when our samples are biased, when they are consistently working to overestimate, or if they are consistently working to underestimate the unknown population parameters. So what we want to see is this. Samples are often wrong, but what we really want to see is that they underestimate the population parameters as often as they overestimate the population parameters. Oops. Think about it like this. Let's say you see somebody is playing darts, and another person over here is playing darts. Okay, so these are supposed to be dart boards. Now, if somebody hits the dartboard with a spread or a distribution of darts that looks kind of like this, they're not really a great dart player. However, they are pointed in generally the right direction. If you were to average out where all of these were, if you look at this distribution, the center is in and around where it's supposed to be, where they're supposed to be targeting. Now, you could have another individual over in this other dartboard, though, who maybe who's even better at throwing darts. They're more consistent. However, there's an obvious problem. On the second dartboard here, even though there's a tighter spread, even though they're doing a great job of throwing in the same way each time, they are clearly missing the mark. They are moved. They really need to be turned a little bit to be pointed in the right direction. This is what would be called a bias. A bias is when you are consistently making the same kind of mistake. When you average out your mistakes, it doesn't really help much. The center of this distribution is right around here. You're not overestimating as much as you're underestimating. You're always kind of making the same sorts of errors. You're always over here too much. Whereas in this first distribution, sometimes you're too much to the left, sometimes you're too much, you're too much to the right, sometimes you're too much to the left, sometimes you're too high, sometimes you're too low, but on average, you're getting to the right point. This is what we want to see with samples. We want to see that they are unbiased. And so, as a definition, what we're shooting for is this. An unbiased estimator is that the average value of the statistic actually equals to the population parameter that we're trying to estimate. So that's like this one here. I certainly don't expect every individual sample to be right on the money, but some samples, if they overestimate, are going to be balanced out by some other samples that underestimate. And so sooner or later, we're going to come to the right value if we keep taking samples, or if our samples get larger and larger and they keep including more and more individuals. So unbiased means that you're accounting for the fact that samples aren't perfect. You're just hoping that they're not going to be always too high, or that they're not going to be always too low. On average, they're going to get it right.